Okay, so hey guys, it's Quinston, and in this video we are about to see how to check with a simple program whether a number is prime or not. We shall start by asking the question, what is a prime number? So a number which does not have any factors and cannot be completely divisible by a number smaller than itself is called a prime number. We can consider the example of the number 8. The number 8 can be factored into the expression 2 times 2 times 2. A prime number by definition cannot have any factors, hence 8 is not a prime number. By the same definition, 8 is completely divisible by 2 or 4, and in the process does not leave a remainder, that is, remainder equals 0. Numbers like these are called as composite numbers and not prime. A number like 23, which has no factors and is not divisible by any number smaller than itself, is called a prime number. Now that we have covered the basics, let us move on to the code. We assign the variable prime number with the number that we want to check, that is in this case 23. Next we want to account for the base cases, the base numbers which are 1 and 2. The number 1 and less are either defined as a prime number nor they are defined as a composite number. Hence, if we encounter the number 1 or less, we must end the program immediately and print out neither composite nor prime. Similarly, if we encounter the number 2, we must end the program and print out the number is prime, as it is a prime number, but the algorithm that we are using does not account for it. So, once we have the base cases out of the way, we can now focus on the method of evaluating whether a number is prime or not. As we discussed in the introduction, the number is prime only when it does not have factors or it is not completely divisible by any of the numbers less than itself. I cannot stress this further, not including 0 or 1, obviously. This actually means that if there is a number between 2 and prime number minus 1, which when divided with prime num divides completely and gives a 0 remainder, then and only then is the number prime. If a 0 remainder is found, as you see over here, if a 0 remainder is found for any of the divisions, then the number is not prime. This is a method that we are going to use to evaluate the number. As seen in the above, in this code over here, we use a for loop to iterate from 2 to prime number minus 1. Which is obviously going to happen with the range function in Python. How do you check if the remainder of a particular division is 0? If you want to divide something and check if the remainder is 0, for that we use the modulus operator. So the modulus operation returns the remainder of the division, which in this case is prime num division x equal to 0. If we find that a number is completely divisible, we print the number is not prime, because obviously if a number is completely divided, then what's the point? And you print the number is not prime, and then you break out the loop, effectively ending the for loop and the program completely. But if the loop goes on for enough amount of time, we check if the current iteration is the last one, and if it is, we print that the number is prime, because there are no more iterations and there are no more numbers to check. And if we go 1 plus, then we reach the number that we want to check, and that is not allowed. We cannot check with the same number. So that's how you do this. So and this is how you write a simple program to evaluate whether a number is prime or not. This is a very primitive implementation, and you can find faster and more advanced method to do the same task. So thanks for watching, guys. Like the video if you liked it, subscribe for more, and thanks for watching. Later.